Oh, friends, today there will be simply an incredible tank. Stock up on tea and cookies. Imagine a tank that is shorter than a person, only 174 centimeters, a turret within a turret that rotates in the opposite direction, homing missiles that can penetrate half a meter of armor. The crew consists of 2 people, both sitting in the turret, hydropneumatic suspension instead of conventional one, and all this in one car. But the most surprising thing about this tank will be at the end, the beginning of the 60s of the 20th century. The Cold War is in full swing. The Soviet Union and the United States compete in absolutely everything: space, aviation, navy, and of course tanks. By this time, Soviet designers understand one important thing: classical tank building is reaching its ceiling. The armor is getting thicker, and regular tank shells are penetrating it less and less. Cannon calibers are growing, but along with them so are recoil, tank weight, and dimensions. Something fundamentally new is needed, and then an idea is born that seems brilliant. What if the tank fires guided missiles instead of shells? The logic is simple and convincing. A rocket flies further than a projectile. The missile can be aimed precisely at the target, even at a great distance. A missile with a cumulative warhead will penetrate any armor regardless of the caliber of the launcher. You don't need a huge weapon with a monstrous recoil. A medium-caliber launcher and a missile guidance system are sufficient. The idea of a missile tank has been in the air for several years. Different design bureaus are trying different approaches. Some people install missile launchers instead of a turret. Others make hybrid systems. But all these machines turn out to be either too big, too vulnerable, or not versatile enough. We need a tank that is small, stealthy, maneuverable, but at the same time deadly. In 1962, the Chelyabinsk tractor plant received a technical assignment to develop a promising missile tank. Pavel Pavlovich Isakov is appointed chief designer. The head of SKB-75 is an experienced engineer who has already worked on several tank projects. Now he faces a task that borders on the fantastic: create a tank of the lowest possible height with the most powerful missile armament, and at the same time maintain mobility, maneuverability, and reliability. The requirements are strict. The tank must be so low that it is difficult to notice and even more difficult to hit. It must carry guided missile weapons capable of destroying any enemy tanks at long range. It must be fast and maneuverable enough to take advantageous positions and evade return fire. And all of this needs to fit into a machine that won't cost as much as a spaceship, and that can be mass-produced. Isakov understands that such a problem cannot be solved using standard methods. Fundamentally new solutions are needed, and the first thing he starts with is choosing a missile system. Without it, it is impossible to move forward, because the entire layout of the tank will depend on the size and characteristics of the missiles. On March 30, 1963, a resolution of the Council of Ministers of the USSR was issued. Work begins on 2 missile systems at once, Astrora and Rubin. Both are the latest, both are promising. Both are capable of solving the problem of hitting armored targets at long distances. Parallel developments, testing, and comparison of characteristics are underway. Designers consider dimensions, weight, reliability, and cost. The military looks at efficiency, accuracy, and penetration. On March 1, 1964, the Scientific and Technical Council section of the State Committee for Defense Technology made a decision. Of the 2 complexes, Rubin wins. Work on the Astra is officially stopped. Now the task is clear. We need to create a tank around the Rubin missile system, and this is where the fun begins, because a Ruby is not a small toy that can be tucked away anywhere. The Rubin complex's guided missile has a caliber of 125 millimeters and a length of 1,505 millimeter. It's 1.5 meters, almost human height. The cumulative warhead is capable of penetrating 500 millimeters of vertically positioned steel armor. The firing range is up to 4 kilometers, which is significantly greater than that of any tank gun of that time. But the main problem is different. The control equipment for the Rubin complex occupies a volume of 200 cubic meters and weighs 180 kilograms. It's like 2 huge refrigerators. Where can you fit all this into a tank if you still need to accommodate the crew, ammunition, engine, transmission, and fuel tanks? How to fit 1.5-meter missiles into the ammunition rack? How to ensure their supply to the launcher? How to protect all this complex electronics from vibrations, impacts, and combat damage? Isakov starts with the main thing. It is necessary to radically reduce the internal volume of the tank. The smaller the volume, the lower the silhouette, the more difficult it is to get into the tank. The first decision, which seems crazy but logical, is to reduce the crew to 2 people. Not 4, like in a regular tank, and not even 3, only 2. Driver, mechanic, and commander, weapons operator. Everything else should be done automatically. There will be no loader. It will be replaced by an automatic loader, which will feed the missiles to the launcher. There will be no radio operator. The radio station will be placed so that the commander can use it. There won't be a gunner either. The commander will take over the gun's aiming using an advanced fire control system. 2 men per tank. It sounds like science fiction, but there is simply no other way to fit all the necessary equipment. The designers understand that there is still a lot of work ahead. It is necessary to design a launcher, develop a loading system, think through the placement of ammunition, create a fire control system, select an engine and transmission, and design a chassis. And there are less than 2 years to do all this. The work is proceeding at a frantic pace. Drawings, calculations, models, testing of individual units. SKB-75 operates almost around the clock. By the end of 1963, the technical design was ready. The production of the first prototype begins. The metal is being put to work. Assembly shops receive parts. The final stage begins. Everyone understands that they are creating something unique, a tank that is unlike anything ever created before. A machine that, if successful, could change the very understanding of what a tank should be. 1964, assembly shop of the Chelyabinsk tractor plant. Workers assemble a machine that many of them don't even understand. The body is unusually wide, but at the same time frighteningly flat. The tower looks as if it was deliberately flattened by a press. No usual high elements, no protruding hatches. Everything is as streamlined as possible, as low as possible, as compact as possible. The design that Isakov and his team came up with truly borders on engineering madness. Let's start with the most important thing: how to place a 2-man crew in a turret so that they can drive the tank and fire at the same time. Normal placement is not suitable. If both sit next to each other, the tower will become too wide. If one after another, it is too long. Some kind of compromise solution is needed. The commander is positioned to the right of the gun. In front of him is the fire control panel, sighting devices and controls for the Rubin missile system. He is responsible for searching for targets, guidance, launching missiles and controlling their flight. In fact, he performs the work of 3 people at once: a commander, a gunner, and a missile system operator. The driver mechanic is located in a small turret. And this is where the fun begins. In a regular tank, the mechanic sits in the hull, looks forward, and drives the vehicle. The tower can rotate as it pleases. It doesn't concern him. Here the mechanic sits in the turret, and when the turret turns, he begins to rotate along with it. They turned the turret to the right. The mechanic also looked to the right. Turned left, he looks left. It is impossible to drive a tank in such conditions. The solution that the designers came up with looks like something out of science fiction. The driver's turret is mounted on the right side of the main turret on a ball mount. When the main turret turns in one direction, the mechanic's turret automatically turns in the opposite direction at the same speed. Result: the driver always looks straight ahead along the tank's course of movement, regardless of which way the main turret is facing. Imagine the complexity of this system. 2 independent rotation mechanisms operating synchronously, but in opposite directions. The slightest glitch and the mechanic will find himself turned around in all directions, losing his orientation in space. But there is simply no other way to place it in the turret and retain the ability to control the tank. To protect the crew from radiation, in the event of a nuclear explosion, special plastic liners were used inside the tank. This is an additional layer that was supposed to weaken the effects of ionizing radiation. Every element is designed to operate under nuclear weapons conditions. Now about how to make the tank as low as possible. Standard torsion bar suspension has a fixed height. The ground clearance is constant and cannot be changed. Isakov chooses hydropneumatic suspension, a fundamentally different system. By changing the pressure in the system, you can change the ground clearance of the tank. Why is this necessary? Firstly, you can lower the tank even lower when it takes up a firing position. Smaller silhouette, less chance of being detected and hit. Secondly, you can raise the tank higher when you need to overcome obstacles. a tank that can crouch and stand up depending on the situation. But hydropneumatics is also complex. Hydraulic lines, cylinders, valves, all of this requires maintenance and is susceptible to damage. The total height of the tank is 1 meter 74 centimeters. This is less than the height of the average man. For comparison, the height of the American M60 tank of the same period is 2 meters 40 centimeters, a difference of almost 70 centimeters. The Object 775 can be hidden behind cover that would make a regular tank stick out in plain sight. Now about weapons. The D-126 gun launcher was developed specifically for this tank, caliber 125 millimeters. The barrel is rifled with 32 grooves. This is not a classic tank gun, but a launcher. The rocket does not need a high initial velocity. It is accelerated by its own engine after leaving the barrel. The system can fire 2 types of ammunition. The first is the Rubin complex of guided anti-tank missiles, a 15-meter-long missile with a cumulative warhead. After firing, it leaves the barrel and deploys stabilizers 3 kilometers away. Penetration of 500 millimeters of steel armor. The second type is the Burr active-reactive projectile with a high-explosive fragmentation warhead. These are unguided munitions for firing at unarmored targets. When you don't want to waste an expensive guided missile, you can use a drill. Cheaper, simpler, and quite effective for many purposes. The weapon is equipped with a semi-automatic loading mechanism and is stabilized in 2 planes by a 216 stabilizer. This is critical for guided missiles, as the slightest deviation during launch can cause the missile to veer off target. 5 TDF diesel engine with 700 horsepower, the same one that would later be installed on the T-64. With a combat weight of about 38 tons, the tank can accelerate to 70 kilometers per hour. For a car of this weight and with such a complex layout, this is an excellent result. The tank's armor is not the most outstanding. The frontal armor of the hull and turret is 120 millimeters. The sides and stern are thinner, but the main protection of Object 775 is not in the thickness of the armor, but in its low silhouette. The best way to protect yourself from an enemy projectile is to avoid getting hit. A tank at a height of 1.74 behind a hill, behind folds of terrain, is a very difficult target. And if you also consider that it fires from 4 kilometers, it becomes clear why the designers focused on stealth. By mid-1964, the first prototype was assembled. The vehicle stands in the workshop, and even against the background of other tanks it looks alien. Wide, low hull, flattened turret, short launcher barrel, minimum protruding elements. This really looks like a tank of the future. There is only one question: will the tank itself have a future? Summer 1964. Object 775 is being taken to the landfill. The first time a tank leaves the factory gates, it immediately attracts the attention of everyone who sees it. The appearance is truly impressive even for seasoned military personnel. The tank looks like an alien from the future. Flattened turret, wide hull, almost complete absence of high elements. The silhouette is so low that it can easily be hidden behind a small hill. The designers are worried. 2 years of work, countless calculations, drawings, testing of individual units. Now all of this has turned into a real machine, which should prove that revolutionary ideas work not only on paper. The military commission is skeptical. Too many new solutions, too many deviations from the classical scheme. But it's too early to judge. We need to look at the results. Sea trials begin. The 5 TDF engine with 700 horsepower starts without problems. The tank starts moving, and it is immediately clear that everything is in order with its mobility. On the highway, the car accelerates to 70 kilometers per hour. For a 38-ton tank with such a low silhouette, this is an excellent indicator. Acceleration is smooth, handling is responsive, and the engine runs smoothly. The hydropneumatic suspension works as intended. The tank can actually change its ground clearance. I pressed the lever, the car sank, became even lower. One more movement, the tank rose, increasing its ground clearance. It looks unusual, even fantastic. A tank that can squat. Such machines have never been seen at the testing ground. The cross-country ability is also impressive. Thanks to its wide tracks and good weight distribution, the tank feels confident on soft ground, goes where a regular car would stall. The low silhouette provides another advantage. The tank is harder to spot and harder to hit. In terms of camouflage, this is an ideal vehicle. The military observers exchange glances. Mobility is excellent, stealth is excellent, cross-country ability is excellent, everything looks promising. And then the shooting starts. And this is where problems emerge that the designers preferred not to think about. The first problem is visibility, or rather its catastrophic lack. The crew sits so low and so tightly packed inside that visibility is simply killer. The commander sees the world through narrow observation devices. The field of vision is limited, as if looking through a keyhole. The driver, sitting in his rotating turret, is practically blind. Observation devices provide minimal visibility, drive a tank in battle, navigate the terrain, and spot threats. All this turns into torture. Yes, the tank is difficult for the enemy to notice, but the crew itself sees almost nothing. Imagine driving a 38-ton machine practically blind. Any crater, any obstacle, any slope can become a surprise. In the conditions of a training ground with cleared paths, this is still bearable. But what will happen in a real battle, in dust, smoke, under fire? The crew simply won't survive. The soldiers make notes in their notebooks. This is a serious problem, a very serious one. But maybe the firepower makes up for the lack of visibility. The Rubin missile system begins firing, and then a second, even more critical problem emerges. The missile guidance system works disgustingly. Electronics of the early 60s had not yet reached the required level of reliability. In ideal firing range conditions, when there is no interference, no enemy fire, no dust or dirt, the missiles more or less fly where they should. But even here the failure rate is alarmingly high. Out of 10 launches, 3 or 4 end in failure. The missile goes off to the side or falls completely before reaching its target. But what will happen in a real battle when the tank is shaking from explosions? When there is dust, smoke, shrapnel in the air, when the crew is under stress, reliability will drop to zero. It went to hell. Second attempt. The rocket did not leave the barrel. Launch system failure. Third attempt. Everything seemed to be fine, but in the middle of the flight the control signal was lost. This is not a weapon. It is a lottery. You'll be lucky. You won't be lucky. The military looks at this and shakes its heads. For that kind of money and that kind of complexity, getting a system that works only occasionally is unacceptable. A tank should be a reliable weapon, not an experimental toy that can fail at the most critical moment. The third problem is maintenance. The tank is packed with electronics, hydraulics, and complex mechanisms. The driver's rotating turret requires constant adjustment and lubrication. The slightest play in the bearings and the system begins to malfunction. Hydropneumatic suspension is sensitive to damage. If a hydraulic line is punctured, the tank will lose the ability to adjust its ground clearance and may even stop dead. The automatic loader is capricious. It either jams or feeds the rocket at the wrong angle or refuses to work at all. The fire control system requires fine-tuning. Electronics of that time were unreliable, overheated, and failed due to vibrations. To service such a machine, highly qualified specialists are needed. Where can we get them in large quantities for the Army? An ordinary tank repairman won't be able to handle Object 775. Engineers, electronic specialists, hydraulic specialists, and missile system specialists are needed. Each tank will require a whole team of maintenance personnel. It is almost impossible to repair this machine in the field. Something serious broke. The tank stopped, and that was it. Evacuate to the factory, disassemble, repair, reconfigure. The fourth problem is cost. The car is expensive, very expensive. Each Object 775 is equivalent to 3 to 4 regular T-64s. The production is complex and requires special equipment, high-precision assembly, and specially trained workers. Mass production would cost an astronomical amount of money, and given the low reliability of the system, it looks like a waste of money. The military begins to count. For the same amount of money needed to produce one Object 775, it is possible to produce several serial tanks with proven weapons. Yes, they don't fire rockets. Yes, they don't have hydropneumatic suspension, but they are reliable, easy to understand, easy to repair in the field, and most importantly, they work. The tests continue for several months. The designers are trying to fix, adjust, improve something, change the electronics, refine the guidance system, and try to improve visibility. But this is patching holes. Fundamental problems remain. The tank is too complicated, too unreliable, too expensive, and most importantly, the crew is essentially sitting in a tin can, seeing almost nothing. By the end of 1964, the military commission issued a verdict: Yes, the tank is technologically advanced. Yes, he is ahead of his time. Yes, it implements revolutionary solutions, but it cannot be adopted. There are too many shortcomings that cannot be corrected without a complete redesign of the concept. Meanwhile, other design bureaus are starting to think in a different direction. Why create a separate complex missile tank? Maybe there is a simpler solution. And this solution is indeed found. It just kills the whole point of Object 775's existence. While Object 775 is suffering during testing, designers from other bureaus are thinking in a completely different direction. The idea is simple to the point of genius. Why create a separate missile tank at all? Maybe we could just teach regular production tanks to fire guided missiles from a regular cannon. We take the T-64, give it a 125mm cannon and make it universal. Can fire both regular projectiles and missiles. No need for separate machines. There is no need for a crazy layout with a crew in the turret. No need for rotating turrets or hydropneumatics. The military looks at this idea and realizes that it works. Indeed, why complicate things? We have an excellent serial tank T-64, reliable, proven, understandable to tankers. We just give him the ability to shoot missiles, and that's it. A universal tool. Do you see an enemy tank at a long distance? Launch the rocket. We need to shoot at the fortifications. Take a regular projectile. Flexibility without complexity. In 1965, they try to shove a Rubin into the T-64. They take the base model of Object 432 and begin fitting the missile system to the turret. And then the problem becomes apparent. The Rubin control equipment occupies 200 cubic meters and weighs 180 kilograms. It's like 2 refrigerators. Where to put them in the already cramped tower? The ammunition stowage needs to be redone. Loading mechanism, change the crew compartment, revise. Plus, a rocket that is 1.5 meters long requires a complete redesign of the layout. It turns out that in order to install a Rubin, you actually need to create a new tank. The work is deemed inappropriate and closed. The Rubin is too bulky, too heavy, too complex. But the idea does not die. The designers understand that the problem is in the complex itself. A more compact system is needed, and they are creating it. The new missile system is called Cobra. It is smaller, lighter, and easier to maintain, and most importantly, it can be integrated into a production tank without radical modifications. The equipment is placed in the missile turret and stowed in the standard ammunition stowage. The fire control system is being modified to accommodate new capabilities. Everything works without any revolutionary modifications. In 1976, the T-64 Billions was accepted into service. A standard production tank with a standard 125mm cannon that can fire both standard projectiles and Cobra-guided missiles. A universal tool. There is no need for a separate missile tank, no need for complex mechanisms, no need for a microscopic crew sitting in a turret and not seeing anything. Just a tank that can do a little more. The fate of Object 775 has been decided. The project was officially closed. One prototype was built. The second one was started to be assembled but not finished. The vehicle that was supposed to be the tank of the future turned into an expensive experiment that showed that sometimes a simple solution is better than a complex one. All subsequent Soviet tanks T-72, T-80, all modifications have the ability to fire guided missiles through a regular gun without any fancy turrets, without hydropneumatics, without a crew of 2. The concept of a missile tank as a separate class of vehicles is dying. Versatility is winning, but the influence of Object 775 remains. Low silhouette as a means of protection. The idea was picked up. The concept of tank destroyers with powerful armament and low altitude was developed further. Hydropneumatic suspension was used in other projects, just not in the form that Isakov envisioned. All the revolutionary solutions were taken apart and implemented where they actually worked. And now the most amazing thing about this tank. Western intelligence agencies only learned about the existence of Object 775 after 1991, after the collapse of the Soviet Union. Until then, the car had remained so secret that there had been no hints about it. No photos, no mentions, no rumors. A complete secret for almost 30 years. When American military experts first saw the photographs, they didn't believe them. The tank is 174 centimeters tall, has a crew of 2 in the turret, and a counter-rotating turret. It looked like a photomontage, like someone's joke. But no. Object 775 really existed. The Soviet Union built it, tested it, shut down the project, and managed to keep it secret for 3 decades. The only surviving copy is in Kubinka, flattened, wide, futuristic. A tank that was ahead of its time but never lived to see it. A vehicle that was kept secret for 30 years and then became a museum exhibit, bypassing the stage of combat use. The pancake tank with a turret within a turret, which proved that cramming all innovations into one project at once is a dead end. The simple solution won over the complex one. The universal weapon killed the concept of the missile tank, the failure of which turned out to be more useful than many successes. Like and comment below to tell us what absurd military equipment we'd like to tell you about next. Subscribe to the channel to stay up to date with new stories.